Okay, so that's all. Then we have proxies. So sometimes you have a browser without remote inspection. And how can you how can you test what's happening between the server and the device? Well, you can use a proxy or a network sniffer. So these are two tools. Fiddler, it's only available officially for Windows, and there is an alpha version for Mac and Linux. It's basically a proxy, so you can set up a proxy on your phone, and then you will see everything that is happening behind the scenes. You also have a lot of connection simulators, because remember that latency? How can I simulate that latency on my desktop? Well, there are a lot of tools available for that. There is even one tool that is right now available on your iPhone that you can enable on settings, okay? That's the one you're seeing at the right. It's the network link conditioner. So basically you can talk to your iPhone and say, I know you have a good 4G connection, but please throttle your connection and emulate a 3G connection, okay? And then you can try and you can experience, okay, the pain of your users. So you have all the links again on the companion website. And finally, we have HTML5 APIs. So we have the navigation timing API, okay, that is basically window.performance that will give you a lot of timestamps directly in JavaScript. So you can query on those timestamps to do things. For example, you can see page load time, DNS, lookups, a lot of information that will give you hints live directly in JavaScript about the current network condition. Okay, so you can make some decisions after that. In terms of compatibility, it's not so good. We have Chrome, some Samsungs, Android only from version 4, okay, and Windows Phone. They support this API. On iOS, it's not available. Because it wasn't available, we had a change.org petition. Apple, please support navigation timing API in Safari. And it seems like that Apple listened to this, okay? Because it was available on iOS 8. However, on 8.1, it was removed. Why? Because of performance issues, okay? And it's not there on 8.3 yet. So unfortunately, it's not there on iOS. Okay, and we can emulate some things on that API because this API, it's about the internals of the browser. Okay, so I hope that this API will be available again soon. I will show you the navigation timing API in a minute. And then we have resource timing API. So resource timing API, it's pretty much the same thing, but instead of getting information about the whole page load process, you get information per request. So on each HTML, CSS, JavaScript, JSON, or image that you are loading, you will receive information about times. Okay? It's only in Chrome and IE 11, unfortunately. The Network Information API, it's another HTML5 API that you can use. Unfortunately, it has 3 different versions of the API, 3 different specs, okay, with the same name, different timing. And we have browsers using one API, okay. The spec number 1 will give you a type value that will say, okay, I'm in Wi-Fi, 2G, 3G. Then the spec number 2 will give you the bandwidth estimation, okay. And finally, the last spec that is available on Chrome and Firefox will give you, again, a type, but differently, okay? But with this API, you can query about the current conditions and do something. For example, the latency is too high, so let's try to decrease the number of requests that we are doing somehow to provide a better experience, because if not, the user will probably abandon my website, okay? So in terms of tools, we need to learn where to test, emulators, simulators, or the real device, and the problems that you might have. You need to learn to measure loading times and responsiveness with these remote tools when you have the emulator or when you have the real phone. And we have some HTML5 APIs that will help us directly live when we are loading the page to make some decisions about it, okay? Now the most important part. So how to improve performance, how to get into that extreme performance situation. Well, first let's talk about initial loading and perception. So we are going to cover again that 1 second threshold, okay, and some other things, including responsive web design. So first, the idea is that after we type a URL and click go, or after we click on a link at Google, okay, we want to see something after 1 second. That's our goal. After 1 second, we want to see the homepage. If not, we are losing users, the flow of the user's thoughts. Remember that thing, 1 second, okay? So instead of 1 second, let's talk about $1. So let's think it's $1, okay? And let's split this into 5 coins. Yes, that's a real coin, right? 20 cents. I have one of those, by the way. So basically, the problem that we have is that the first coin on a 3G connection, that's the average, it's being taken by the DNS lookup the first time that you're accessing the website. The second one by the TCP connection. Then the request with all the headers from the phone to the server. Finally, the server that is sending something, okay, back, the response. So we have only 1 coin for the rendering to show something. So that's our problem, okay? And I'm sure you're thinking, hey, do you expect the page load in 200 milliseconds? Well, sort of. We need the perception that the page is there in 200 milliseconds, okay? So that's the idea. And for that, we need to avoid 2 signs, the please slow down and stop sign that we are using all the time on our website. So let's explain this. Quickly, basic browser behavior. First, network fetch. Then parsing, so reading and understanding the HTML, and finally rendering, okay? So HTML, JavaScript, and CSS, we can have slowdown signs and stop signs before the HTML, so before delivering the HTML to the network. And then JavaScript will block parsing, and CSS will block rendering. So every time you have JavaScript, it will block the parsing. So while the JavaScript is being downloaded and executed, nothing is going to be parsed. Everything is halt, so it's a stop sign. The same happens with CSS. When you have CSS, when the browser knows there is a CSS to be parsed, it won't draw anything on the screen until that CSS is downloaded and parsed, okay? So those are our stop signs. So the first please slow down sign are basically redirects. So I'm pretty sure you know about redirects. And the redirect will take from 150 milliseconds to a full second. It's when you are going from one server to the other, okay? So for example, from mydomain.com to m.mydomain.com, that's a redirect. It needs another DNS prefetch, another TCP request, another HTTP request, blah, 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 blah. Now, in this era, it's even more complicated because we have URL shorteners that we are using on Twitter, Facebook, or emails. So when the user clicks there, first you have that redirect before yours. And that's a problem. So for the demo, and I'm sure if the Wi-Fi is working properly, but I took a video an hour ago. So this is the American Airlines website, okay? So using the API I mentioned before, okay, the navigation timing API, you can query dynamically on JavaScript how many redirects do you have at one point. So in this case, well, they have a lot of JavaScript errors, but this is nothing against American Airlines. In fact, it's my airline, right? So window.performance, okay, will give you an object, and on that object you have navigation, and redirect count give you a 7. Okay, so 7 redirects before getting into the homepage from a mobile phone. So they are losing between 1.5 and 7 seconds for nothing. Okay. So why is that? And let's say I'm on Facebook and I'm clicking on a link. Okay. So I'm clicking on a link on Facebook on my mobile phone. So this is what happens is that first Facebook has its own redirect. It's called the L.php. Okay? Then it's bit.ly, URL shortener. Then aa.com. Then the server says, no, here, it's not here, it's in www.aa.com. Then it says, oh, you want the homepage. Okay? Then the server realized that you're a mobile phone, and it's redirecting to mobile.aa.com, and they say, oh, you want the M, and then you want the homepage. So this is an extreme example, but there are a lot of examples like this out there. So don't do this. Don't redirect. Okay? There is no need today to do that. I know that you can say, well, infrastructure says that blah, blah, blah. You can solve the problem. Okay? And if you are going to do a redirect, do just once. Make all the questions at once on the first request. Okay? So now let's talk about the stop signs. The first one, the app banner, that I like to call app spam. Okay? And talking about airlines, Delta.com, okay, it's losing from 1 to 5 seconds because of this. So you type Delta.com, and instead of the Delta.com website, you have this. Okay, get my app. And it's not about airlines. There are a lot of websites. I'm pretty sure that you know this, okay, as a user. How many of you have downloaded the app from that link? No one, right? This is a great tweet. Number of times I have downloaded the free app instead of continuing the mobile website, 0. Okay? And you're stopping the user to get the information that he or she is trying to get. And probably the user is not trusting you yet. So it's not going to download the app. Okay? So don't do this, because you are just harming performance badly. Okay? And usually it's a very big banner, okay, and with a lot of CSS and things like that. And even there is a website, right, I don't want your beautiful app, that is gathering all these examples that you can find on the web. So don't do this. There are other easy and nicer ways to do this. And the other thing that I'm not sure if you're aware, and that is it's something interesting, is the 14K limit. So that's the round trip. Remember latency? So on TCP, I'm not going to start talking about TCP and low-level network here, but basically TCP works with packages. So we need to retrieve the home page in one TCP package to avoid more round trip times that we have has a big latency, even on 4G. So to do that, well, there is something called TCP slow start. It doesn't matter at this point why. But basically, there is something called the initial congestion window that is roughly 14.6K. That means roughly that on your first response, if your HTML, for example, is more than 14K, then it's going to make a new round trip. So another latency. Okay? So we need to avoid this. Okay, that's a big issue here. What? The page content in 14K? Well, first, it's 14K compressed if you're using gzip on your server. So it's around 70. It depends on your HTML and CSS. So for doing that, we need to separate what is now known as above the fold content from the rest of the content. So the above the fold content is basically the content that you're seeing on the first view on a mobile phone. On a mobile phone, usually websites are really large, okay? So we need the perception of being there in 1 second. How to do that? Split your website, okay? There are different techniques to do that between the ATF content and the rest, okay? And try to deliver everything in 14K. Everything for the ATF content. Usually the ATF should be a little more because we have taller devices, but it should be like 50% more than the first view there. So, because if we can deliver the ATF content in 1 second, okay, it means one round trip. it means 14K, okay? So that's the thing you need to remember to get extreme performance on mobile devices. And this is something in TCP, so it will work on every browser because it has to do with the network layer, not with the browser. So everything, HTML, CSS, and JavaScript, should be inside that first request. That means inline CSS and inline JavaScript. Okay. What about images? Well, maybe images is not. We can embed images using data URI, but that's not a good idea. I will show you an example in a minute. Because with images are non-blocking by default. So remember the stop signs? We have stop signs on JavaScript on CSS, not on images. So, and if we are sending those images on the HTML, we are converting that image into a blocking image. So unless we are talking about the small images, usually it's not a good idea to embed images on that first view. So how to embrace ATF content in 14K? Well, don't use JavaScript framework. Don't use jQuery. We love jQuery, right? But if you add jQuery there, we are out, right, of budget. Remember that $1 we have? So we don't want to get out of that budget. So embrace vanilla.js. That's basically plain JavaScript, for the ATF at least. If you really need them, load them after ATF, somehow. There are different techniques for this. Think of alternatives. There are alternative frameworks or partial framework. You can create your own version of jQuery just with the things that you need. Careful with data URI in CSS. So embedding images and icons inside the CSS because we are converting images to a block because now they are inside the CSS, okay? So use them only on the CSS that is the non-ATF CSS. So we're going to split our website, okay? That's the extreme situation. That's the title of this session. So here you have an example of that you can run in your phone. Remember, you have a live test there on the companion website. You can run this example, so the same image with an IMG tag and then with data URI. If you look at the DOM thing there, you can see that on the first one, the DOM is being loaded in 18 milliseconds, and the other one is taking 3 seconds. Because the DOM will be ready, and the DOM means also the page load animation on the browser. Okay, it's going to be ready only after the image is there. So you have a problem there because now you have a blocking image when you're using data URI. Careful with client-side frameworks, for example, jQuery Mobile, okay, or others. Why is that? Because before seeing something, the full JavaScript and CSS for that framework needs to be loaded. So we have a problem, that dollar budget. So one solution, and there are some solutions out there to do this automatically, you can render that initial view server-side, okay? So that first view is server-side render, at least a basic view. Twitter did a research here, and they changed their twitter.com homepage from client-side to server-side, and they increased performance perception in 5x for doing this, okay? Web fonts, another big issue here. That particular thing where you are not seeing anything. And if you have your mobile phone with you, then access the live test on the link I mentioned before, and you will try this yourself. The web fonts are blocking the text rendering. And fonts are usually bigger than 14K. So you can remove characters, simplify glyph, but you will always have a problem here, right? So try to don't use this on ATF. There are a couple of techniques to do that. Basically, you are going to change the fonts dynamically or something like that. But if not, you have problems like this. So you see nothing, 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 and then you see text. Okay. So on the red thing there, right, there is text there, but you're not seeing the text until that font is being loaded. Okay, and that's more than 1 second. And responsive web design, okay? Again, that big topic. Media queries are blocking rendering. So let's say you have 4 CSS, 1 for tablet, 1 for desktop. So the problem is that every phone will download all the CSS, not just the one that you think it's being loaded, okay? So here you have an example that you can run on your phone, So I have some media queries, okay? And then I load this on a mobile phone where only one media query is being used, but all the files are being downloaded. And the browser will not render the website until all those files are being downloaded. Remember all the latency, blah, 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 blah. So that's one of the problems, okay, on responsive web design by default. I'm talking about responsive web design by default. And then the ATF content on mobile is unique. So that means that on a desktop, the above default content is not the same. Okay, it's bigger. So if you want to achieve that above default content on most situations, you need to provide like two different, from server side at least, two different HTMLs, to mobile and desktop. There are some situations, there are some websites where you can fit also the ATF content or everything for desktop in 14K. And then you can use responsive web design without any issue because it fits into one TCP packet. So don't rely on responsive techniques for the first view if you want to be as fast as possible, for the first view at least. But you can say, hey, but responsive web design is the future, right? Everything is talking about responsive web design. Well, I'm not saying that you should create another URL, right? A mobile separate version. Because, oops, wrong button. Because using the same URL is still a good idea because we are using social networks, we are sharing things on the net, on social, on Facebook, on Twitter, and I don't know what device my friends will have. So using the same URL is a good idea. You can mix this with other techniques. REST, adaptive web design. You can load media queries asynchronously. Or you can use server-side libraries to split your responsive web design. Okay? There are a lot of libraries to do this. You have the links if you want to get more information. After the above default content is ready, then you load the rest of the content. And while you are rendering the ATF content, you can gain experience. For example, about the current performance, screen density, bandwidth, and when you are loading the rest, you are smarter than on the first load. So you can increase the experience on the rest of the content, because if you know that the user is on an iPhone 6 Plus, but it's in roaming and the connection is not working so good, it doesn't matter the device. Okay? So now you can decide maybe to load low resolution images. Okay? So you make smart decisions client side, like HD or SD. So you should load scripts asynchronously, okay? Because if you do that, and you can try this on your phone, you will see the difference. So when you load a standard script, okay, in this case, I'm forcing this for 4 seconds. You see that for 4 seconds, nothing happens. 1, 2, 3, 4, or 5. Nothing happens. You don't see the page, okay, because the JavaScript is taking 4 seconds. But if you see the other option, okay, that's using the async attribute, the page is there, okay? Now it's loading the JavaScript, but the page is there. I have something in 1 second, in less than 1 second for the user. Then you need to see how to solve the problem, what happens if the user is interacting with the website before the JavaScript, but that's a less important problem, okay? This is more important. So, how to defer the CSS that you are not using in the first view? It's not so simple because we don't have defer or async attributes yet on HTML for CSS, but there are some tricks, such as injecting the link after the rendering, or using request animation frame. That is for animation, but the first execution means that the page was loaded. So when the first execution of request animation frame is running, then you inject the new CSS you need to download. So it's a trick. And you can speed future visits, being cache friendly, using app cache. That is a tricky API. So the next time the user is accessing your website, you will improve the experience, and you can create a custom cache. There are a couple of solutions out there for this. Like, the problem is that you are using users' storage for this, local storage or database. So for the initial loading, remember, we need the illusion with the ATF to load the page in 1 second. No redirects, no scripts, no frameworks for that particular ATF, and only the ATF CSS having care with fonts, okay? That's the biggest issue here. And finally, responsiveness and experience, because that's also part of what the user thinks about the performance of your website, that, remember, means your money, okay? Because here we are just talking about money at the end, like always, okay? Sex and money. In this case, it's money. So here you need to care about experience, the frame rate, feedback, the scrolling, and a new enemy. So optimize your content for mobile means that the user will perceive your website faster. Again, Delta. Delta is asking me for a flight number, but the keyboard is not for numbers. So it needs, for me, more touches to get the number. Okay, so the final experience is worse. About the frame rate, okay, you need to try this directly using the remote debugger and see what's happening. So avoid manipulations in loops or scroll. While the user is scrolling, don't do anything. Okay, because you have I'm pretty sure that as a user, you have experienced websites that you are trying to scroll and it's not working, right? Or it has problems. That creates a really, really bad experience. Do you remember that idea of immediate mean 100 milliseconds? Well, the click, this is not new, but there are still a lot of people not knowing this. So by default, when you click on a mobile website, it's taking 300 milliseconds, so it's more than 100, to fire the click event handler, even on normal links. That's because of the smart zoom that, for example, the iPhone has. So when you're using a mobile viewport, for example, the viewport content width equals device width, Chrome, for example, will reduce that delay automatically for you. But on iOS, it's not happening. So you can use FastClick. That is, it's a solution. It's an open source framework that you can use that will improve that feedback when you click. Okay. So on Chrome, you just need the viewport. You also have something for IE. Okay. For IE, you need to add the user scalable node that has some usability and accessibility problems. Also on IE, you can add some CSS for this. Okay, that will help you on reducing that delay. Okay, I think, no, we don't have time for demo. You can distract the user. Do you recognize that thing? That's Facebook. Okay, Facebook on the web. While it's loading things, it's showing you a quick animation. So from a user's perspective, that means that you are keeping the user engaged with your content. So instead of nothing, instead of blank, so the user say, oh, it's coming, right? So I'm keeping the user's flow of thoughts inside my website. In terms of storage, if you are using local storage, Web SQL, or IndexedDB, you need to realize that some of these APIs are synchronously. So that means that when you click, if you are saving something, the click will use, that saving operation will use the same thread as the UI. So we will stop the user to see the feedback, okay? So you have some demos on the website where you can try on your phone different situations and then decide which one is better. And about the scrolling, avoid repainting, use touch overflow. That's a CSS extra property that we have on modern mobile browsers. Don't use JavaScript scroller, right? So some JavaScript APIs that will help you create fancy scroller. Don't use that because today, at least, it's a very bad practice for performance. I already showed you the demo of the scroll, so I already did that. And finally, your new enemy. So you have a new enemy. It's not the user. Okay, the user is not our enemy. It's the designer, and maybe it's you. Why is that? So maybe it's you. You are your own enemy. Okay. Because there are a lot of problems with GPU, okay, and CPU. So, and this is really important when you are scrolling or you are making transitions or animations. For example, if you are using border radius, gradients, shadows, or filters, it's CPU. So that is harming a lot the scrolling operation. Okay? So if you're using those things, it's not hardware accelerated, so it's basically taking frames from the scrolling animation. And it's taking your money. Okay? So some other things are hardware accelerated, so it won't harm performance. So you can try this directly on the remote debugger. So if you profile your website, you will find those things. And maybe you need to go to design and say, I'm sorry, I need to remove that shadow. Okay, because that shadow is taking our money, basically. Right? It's not easy to say that, but you can try. So remember that feedback in 100 milliseconds to keep a consistent frame per second rate. Don't do CPU repaints. Embrace the GPU. Okay, it's not simple, but it depends on your design, basically. But when you understand that and you test and measure that, then you realize that maybe one thing that you are using is basically crashing your performance. We have covered a lot. I still have 5 times. So the mobile web today, remember? So how the mobile web looks like, the mobile performance, so performance, mobile, all this idea of the latency, the round-trip time, tools, emulators, simulators, debuggers, initial load and perception, 14K, okay, the illusion in 1 second, the illusion that everything is there in 1 second, and responsiveness and experience. So remember, on that link, you will find the slides, all the links I mentioned, and all the tests and more. So you can try directly on your phone different versions of the same test. So you can take your own conclusions there. Final thoughts, measure and profile on the real world. Okay? Don't rely on your desktop browser that is being resized. Don't redirect. Reduce your request to the maximum. Remember latency. ATF content in 1 second, defer the rest. I know it's not easy. It has a cost, but remember it's money. Be simple and be aggressive when you're talking about mobile. Remember that you are not an average user. Okay? And finally, remember I have office hours tomorrow. I will also have a book signing. So if you're a lucky one, you will probably get a book. That's also tomorrow. And my books and all the books on the web are today 50% off. Okay? Questions? So thank you first. Questions? We have 3 minutes for questions. Yeah. Okay. Oh. The URL, yeah. Question, yeah. We don't have a microphone, so I will repeat the question. Okay, so the question or the comment is that there is a solution for Android browser, right? There are a couple of solutions, but unfortunately, those solutions are JavaScript based. I'm not sure which one they mentioned. The other solutions means, like, because the Android browser is open source, you can take that code and inject something there, okay? So there are a couple of solutions, but like Winery, but Winery is JavaScript based, meaning that you cannot profile JavaScript because it's the JavaScript that is executing. So you can debug your HTML, your CSS, but not your JavaScript. So it has some limitations. Yeah. Oh, the question is, how can I realize that the URLs that American Airlines is using? By the way, these are just a short version of the real URLs. But if there are different ways to do that, so how can you realize that they have 7 redirects and which redirects they are using? So you can use a proxy for that. So if you install, for example, Charles Proxy or Fiddler on your computer, and you open the simulator, and you go to a URL, you will see there all the URLs that are being requested. So you can realize that there. Well, I think we are on time. So if you have any other question, we have 1 hour tomorrow for office hours. Okay, we can sit there and chat. And I will be here. So thank you again.